Hi there. Here's a torch. Now, you probably have used a torch before if you ever went camping or something. You probably know there's a button right here, and if you click it, the torch turns on very easily. And it's really easy to operate a torch. And although it seems simple, something much more complicated is actually happening behind the scenes. This is controlled by something called electricity. Electricity is controlled in something called circuits.
Okay, so how exactly does the circuit work? Well, in order to understand that, we're going to need to talk about electrical charges. So if you've ever rubbed a balloon in your hair and then stuck it to your head, you've experienced electrical charges. Basically, there are two kinds of charges. There are positive charges, and there are negative charges. And charges that are the same will repel, charges that are opposite will attract. So if you have two positive charges next to each other, since they're the same, they're going to push each other away. They don't want to be close to each other. And same for two negative charges. They'll repel and go flying apart. On the other hand, what if you have a positive charge and a negative charge next to each other? Well, since they're opposite, they're going to attract each other. They want to be as close as possible. Everything in our world is made of atoms. You, me, the table, this chair, the wire, the light bulb, the battery, the switch, they're all made of atoms. So at the center of an atom, there's a positive charge. It's kind of sitting in place, and it's called the nucleus. There's a positive charge called the nucleus, and around it, there are a bunch of little tiny electrons. They're negative charges, they're zipping all over the place, and they're called electrons. And these electrons, they're kind of like two toddlers that ate too much sugar or something. They're super energetic, they're running all over the place. And the positive charge at the middle is like their parents patiently supervising them. And remember that this means that the electrons aren't going to want to get too far away from the positive charge at the center. They're going to stay pretty close. These two opposite charges, they are being pulled towards each other. So what exactly does all of this have to do with circuits? Okay, so what exactly is happening in this circuit? So the battery, remember, it's made up of atoms like everything. And basically what happens is there's a big wall going through the center of the battery. It takes the negatively charged electrons away from the atoms on this side, and it moves them to the other side of the wall. So that means that there's a lot of negative charges on this side of the battery and a bunch of positive charges over here that are missing their electrons. So this means that this side is super negatively charged. And remember that negative charges, they don't like to be with other negative charges. They like to be with positive charges. So the electrons over here, they would really like to run back over and be next to the positive charges. But they can't because there's a wall here. They can't just go over. And so instead what happens is they need to find an alternate route. And the circuit is what allows them to do that. So take a negative charge over here, for example. It is repelled by all the negative charges surrounding it. And so it's going to run down this wire into the light bulb, and then it'll run up through the light bulb, and then it'll run down this wire and to the switch. And then when we close the switch, it'll be able to go all the way to these positive charges, which will be attracting it. So we can see in the simulation, these little blue balls are running through the circuit. And when they run through the light bulb, that's what makes it light up. So that's how this circuit works.
There are two types of circuits. The first one I'm going to show you works like one continuous loop, like this. Now, right here, we have the light bulb, and we have the battery right here. This type of circuit is called a series circuit. Now, let's say we have a switch in the circuit. Now, this switch can be open like this, or it can be a closed switch like this. Now, a closed switch means the circuit is fully connected, and that means electricity will flow around the entire circuit and the light bulb will turn on. But when you open it like this, the electricity will stop flowing and the light bulb will not turn on. Next, we have our second type of circuit. This is different because it has multiple loops connecting the same circuit, and this can have a battery, bulbs, and it is called a parallel circuit. Parallel circuits can be connected in loops of 2 or more. Now over here we have a parallel circuit with 2 bright lights and a switch. Now these bulbs are on because the switch over here is closed and connected. Now let's say we open the switch. Now if we open the switch, the top bulb will shut off. And this is because the electricity is flowing in the lower loop, but it cannot flow in the upper loop because it's disconnected. However, one light bulb will still stay on because one loop is complete. Now let's go back to the series circuit for a second. If we add another light bulb to the same series circuit and we open the switch, both the light bulbs will shut off. This is because when it's disconnected, neither bulb is receiving electricity and there is no complete loop. Yet, in the parallel circuit, if we open the switch, one of them will stay on because one loop is still complete. Our homes mostly use parallel circuits because if one of our wires are damaged like this, then all the lights won't shut off. Now, you've seen the symbol for a light bulb, which is basically the circle with a cross in the middle. This is a universal symbol for a light bulb, but this is what a real light bulb looks like. Now let's take an empty light bulb. If we want to turn it on, we let electrons, like we talked about earlier with the negative charges, flow through the light bulb, and then it turns on. Now, this is a symbol that I've drawn for batteries. This is also universal, and the plus and minus sign represent the positive and negative charges. These batteries are used to provide a push of energy that we call the voltage. This is used to push electricity around the circuit. This is an example of a battery. These are not rechargeable, which means that once they run out, they have to be replaced, like the ones in most torches and toys. Now, some batteries, such as the ones in iPhones, are rechargeable. All you have to do is plug them in a wall and they recharge the battery. But even iPhones have complicated circuits inside them, and so do electrical heaters, televisions, and anything powered by the grid. And so electricity is very important to society.